Hello everyone, I am hydrochloric citizen. Today I'm about to prep a buffer solution in different ways. So I have just started creating work 6 workbenches, and I have named workbench 1 as water and 2 to 6 as A to E respectively. So first we have to have in a water workbench we have to have a two 200 ml Ellen Mayer flask. Need to organize it, and then a distilled water. Then pour a precise amount of 30 ml to each one of them. Then we have to remove it for an organized workbench. So if you have noticed, the water pH is at 7 or at normal, neutral pH. So then in this first flask, we need to have a hydrochloric acid, which is strong acid, 1 mole of hydrochloric acid. Then we need a pipette in a glassware, and 5 ml would do. Then we draw a 2.0 ml of hydrochloric acid. The hydrochloric 3.0, then pour it into the first flask. As you have seen, the water pH and combined hydrochloric acid is now have a 1.2 pH. And the second one, we need a sodium hydroxide, which is a strong base, 1 mole of sodium hydroxide, and pipette it, pipette a 2 ml. After, then pour it. Now our solution has a pH of 12.79. We need to remove this one to organize our workbench, and we'll rename it respectively. So this one is an asset. Now this one is base. So for our A to E workbenches, this table will be our guide to prep a buffer solution. But since our acetic acid, sodium acetate 0.10 mole, is not available in our stock room, we need to prep the solution. So to prepare the said solution, we need to go to our solutions, then under the weak acids is 1.1 molar acetic acid. Pardon, it's one, should be 1 molar acetic acid. And then we need a volumetric flask, 100 ml will do, and water. So let's pipette a 10 ml of this acetic acid, then pour it to our volumetric flask. After such thing, we have to remove these. And realistically, we don't have to pour the 90 ml of distilled water directly into the volumetric flask. So we need a beaker, and then we pour a 90 ml of the distilled water. And then we'll pour it into our flask. So that is so now we can rename it as 0.1 mole of acetic acid. On the other hand, the sodium acetate is a conjugated base. One mole of sodium acetate will do. Then we'll go through the glassware volumetric flask, 100 ml, a pipette of 10 ml, dispense amount needed, then pour to the flask. To organize, we have to remove them, the unused one. Then pour a 90 ml of distilled water. There we have it, a 0.1 sodium acetate. As the table suggests, we need a 15 ml of acetic acid and 15 ml of sodium acetate. So we need another Erlenmeyer plus 200 ml will do. And then we will dispense the amount needed for the solution. 15 ml. Always make sure to have the precise number. And on our sodium acetate, we need also to dispense 15 ml. pour it. So there you have it. We have a solution of having a 4.76 pH. In a table, buffer B suggests that we need 0.10 mole of acetic acid, a 0.10 mole of sodium hydroxide, and a 750 ml of hydrogen monoxide. So in here, I have already prepped the zero point 0.1 mole of acetic acid. All we need to do is to have the sodium hydroxide, which is a strong base, a 0.1, I mean a 0.1 sodium hydroxide, and of course the distilled water. So we need again and Ellen Mayer flask. We need to pipette this an amount needed for acetic acid is 15 ml. 15. Then withdraw, and then pour it. We also need to pipette 7.50 ml of the sodium hydroxide and pour it into the flasks 7.50 ml. And the water, we need to have a graduated cylinder, 10 ml will do. Then pour it in there. And we need 7.5. Pour it. And then we'll pour it directly to the solution, 7.5 water. So to organize, we need to remove the unused glasswares. So there we have it. We have the buffer solution having the pH of 4.76. The buffer C, as the table suggests, need 0.10 mole of sodium acetate, 0.10 mole of hydrochloric acid, and the dihydrogen monoxide or water. And here again, I have already prepped a sodium acetate, which is needed. And then we need water and hydrochloric acid, which is a strong acid. 0.10 mole of hydrochloric acid. Again, to prep a buffer, we need an Erlenmeyer flask, 250 ml. We need to dispense, as the table suggests, a 15 sodium acetate, 15 ml. Pour it to the flask. And we also need 7.50 ml of the hydrochloric acid. We need a smaller pipette for that. 7.50 ml. We draw and then pour it to the solution. 7.50 ml. After that, we need also a graduated cylinder for the water. 10 ml will do. We need to organize the bench work. And then we pour the needed amount to the cylinder. 7.50. Then we'll pour it to the solution or buffer solution C, and we'll be removing the unnecessary glassware for the workbench to make it organized, like this pipette too. Yes, there you have it. Our buffer C is having a pH of 4.76. Buffer D, as the table suggests, needed 2 an available solution in the stockroom, which is the 0.10 mole acetic acid and 0.10 mole of sodium acetate. But in here, I already prepped the 2 of them. So all we need is Erlenmeyer flask, 250 ml. Then dispense the amount needed for the buffer solution, which is 25 ml of the acetic acid. Withdrawn, then poured to the flask, 25.0 ml, then pour, and we need the smaller pipette, 5 ml, 0, dispense 5 ml of the sodium acetate. And pour it to the solution. So there we have it. We have a buffer D solution with 4.06 pH. In a table, buffer E needs 1 mole acetic acid and 1 mole sodium acetate. So we need weak acid, which is the acetic acid, 1 mole acetic acid, and a conjugated base, which is the sodium acetate, 1 mole of each. Then all we need is a glassware, Allen Mayer mass of 250 flask. Then dispense an amount of 15 ml each of them, 15 ml of acetic acid, pour to the solution or the flask rather, and then also dispense 15 ml of the sodium acetate and pour it to the solution. So there we have it, a buffer E solution having a pH of 4.76 pH. So to keep track with each of the buffer solution, we need to duplicate it and rename it accordingly to what next step would be. Duplicate, and then rename acid, A acid, then A plus based. Same goes with B2E buffer solution. Duplicate it, rename it with B plus acid and B plus base. Same with C, duplicate, rename, and then same with the D solution. We need to duplicate and rename it accordingly. And E solution. After duplicating and renaming each of the buffer solution, we need to add a hydrochloric acid for the plus acid name, which is under the strong acids. One mole of hydrochloric acid, which we need, and then pipette a 2.0 ml. Withdraw and then dispense to the acid name. As we have noticed, this first pH buffer solution has a pH of 4.76, and as we pour our 2.0 ml of 1 mole hydrochloric acid, the pH dropped to 1.8. We have to remove to organize. Then we need to add a strong base, which is the sodium hydroxide, to the base. Dispense 2 ml. From 4.76 pH, our buffer solution, after pouring a sodium hydroxide, will get 12 point lowering down 19. Same way with the buffer B solution, we need a strong acid, hydrochloric acid, 1 mole of hydrochloric acid. Dispense using a pipette a 2 ml of it. Draw and then pour it to the acid buffer solution indication. 4 from 4.76 it become 1.41. Next is the sodium hydroxide, 1 mole of sodium hydroxide, and then pipette it 2 ml. Then from 4.76, the buffer solution would be around 12.59 as it down to 25 degrees Celsius. Same with buffer C. We need a strong acid of hydrochloric acid. Dispense 2.0 ml. And then from our buffer solution of 4.76 pH, it would become 1.41. For C plus base, we need a strong base, the sodium hydroxide, then dispense another 2.0 ml. Then from 4.76 pH, our buffer solution would get at nearly 12.59 at its lowers to 25 degrees Celsius. Same with the buffer D solution. See, we also need to dispense a strong acids of hydrochloric acid, 1 mole of hydrochloric acid, and a strong base, sodium hydroxide, and then using the pipette, we have to withdraw a 2.0 ml. Then from 4.0 pH, now our buffer solution would be dropped to 1.33 pH. On the other hand, by dispensing a 2.0 sodium hydroxide, our D-base buffer solution from 4.0 pH would get a nearly 5.46. And lastly, for our buffer E solution, we would do the same thing. Using the strong acid of 1 mole hydrochloric acid and strong base sodium hydroxide, we need to dispense 2 ml using the pipette, 2 ml of the hydrochloric acid to the respective indicated name, 2.0. So from 4.76, pouring a hydrochloric acid to the buffer solution, the pH would become 4.64. So let's remove the already used one. And then A plus base solution, 4.76 pH, dispenses 2.0 sodium hydroxide. Then as we pour it, we'll get roughly 4.87 pH. So there you have it. After adding a strong acid and a strong base to the buffer solution. B acid, B base, C acid, C base, D acid, D base, E acid and E base.